So welcome to this tutorial on monitor calibration from Azo. In this tutorial we're going to show you how to calibrate the CG319X and the CG279X with a program called ColourSpace from Light Illusion. So ColourSpace comes in a variety of versions. The entry-level version that will allow you to communicate directly with the Azo monitor is the LTE version and the CAL versions. These versions allow you to use the I1 Display Pro or the internal probe, also the internal test pattern generators of the Azo CG319 and 279Xs. If you have reference probes like the colorimetry CR100 or the Klein K10 or Minolta, then you need to use the more professional versions of ColourSpace. So at the end of the tutorial with calibrating with ColourSpace, you will be able to have a monitor that will be suitable for the most critical color grading work. So here we are with the ColourSpace window opened on the computer. At this stage you should have also connected the Azo monitor to the computer via the USB 3 cable that comes with the computer. It's an A to B type cable, and that'll allow ColourSpace to have control over the monitor. So when you open ColourSpace, you'll see that the four icons, which is the one on the left is the management, the second one's the profiling, the third is the LUT tools, and then the fourth is the reporting. So to get started, we just simply click on the profiling tab, and then you'll open up this window here. So on the left hand side we have all our various graphs we can look and view. Here we have the first icon here. I always like to travel from left to right and go through the setup that way. So you can choose your target gamut and EOTF. So today we're going to be choosing Rec 709. The target luma, we'll populate that shortly, and that's important because that will, the delta E errors are basically take a reference to these values in the min-max. On the right hand side we have the patch size window, so we're going to be calibrating with the internal patch generator, so we're going to leave that on full window, but you can choose other window sizes as well if you wish using external probes. The patch scale, it's a full scale full range test pattern generator within the Azo, so we leave that at full, but you can use other test pattern generators depending on the signal path, and the signal path is the most critical component of the calibration of monitors. I think if you need to make it, if you're sending legal, you must scale to legal. If you're sending full, you must have it at full as well. So we leave that at full. No need for any pre-roll in this. The second tab is the probe options. So there's various different options you can do. There's the I1 Display Pro OEM. There is a way to connect the standard retail version as well. If you speak to Lightspace, Light Illusion, they'll help you out there. When you do that, if you're using the I1 Display Pro, the correct phosphor setting is the RG phosphor for the CG319 and the 279, and we use the intelligent integration as well just to help with the low light read. The integration time, I found that 0.75 works pretty well, and I've just added a little bit of extra delay there as well, 0.25. If you're using a network in particular, you probably want a bit of delay in there. If you're using the probe matching, that's all set up in this area here, which you can find that information out on the Light Illusion website. We will be providing offsets for the I1 Display Pro to use with ColourSpace, and that'll be available shortly. But for today's tutorial we're going to be using the Azo Internal Probe, and for that you just simply connect, and ColourSpace will talk to the internal probe within the monitor and set itself up. So you can see we've got the probe running now, and a lot of areas are greyed out because that's taken care of by the system inside the monitor by itself. You don't need any extra delay with the internal probe, and again you can use probe matching with the internal probe as well if you wish. So we're ready to go with our probe. So our test pattern generator, there's a variety of them you can use. You can use the network, so if you're using Resolve or various LUT boxes, but we're going to use the internal test pattern generator within the Azo monitor itself, so you don't need to buy an external test pattern generator or worry about full range levels and that sort of thing. So you can see that's connected, and it's come up with the monitor here, the CG319. If it's a 279, it'll be exactly the same, and if it's a 247X, it'll say that as well. In the LUT processor, you only have one choice, which is the extended. The interactive controls here allows you to set the luminance level, backlight of the monitor as well. Now, a really important step to choose within the test pattern generator in the EIZO, because there is two of them, is the standard or the emulated. You want to choose the emulated because what the emulated does, that's before the LUT. So when we actually profile, create the LUT and load that into the monitor, the emulated test pattern generator will allow us to go and verify that LUT correctly. If you use the standard, that's after the LUT, so you can't verify the quality of the LUT that's been created in that. So we use the emulated. You then go and put the calibration patches to automatic, and then when you do that, you should see the screen go to black. Now, very importantly, you must also make sure you select the right mode on the EIZO, because you can overwrite the presets within the EIZO. You can go and reset them back to where they were, so it's no real problem. But we're going to be calibrating the cal slot, so it's important to, before you do any profiling and calibration, is to select the right slot on the EIZO monitor. And once you do that, we upload a Unity LUT. And the reason we do this is because we want to make sure that there isn't any previous LUT in there, and we put all the system back to a null value, which is its native value. The fourth tab is the graph options, which we'll come back to that later. If you are using probe matching, you need to go and select the probe matching active to see the results of the probe matching working on the profile and the verification. In the tab here we have the manual measure, so I always like to start off to just check and make sure that the test pattern generator is working the way we want it to work, and to just do a measure. And then at that stage you'll hear the probe come down, and then it'll start doing its measure. So you can see we've got a value of 109 nit within here, and the monitor is just a little bit blue compared to what it should be for a D65. So that's just a bit of a tester there. And to actually do the profiling, we go into this last characterization. So in here we have a variety of choices. Normally for a full 3D LUT calibration you would use a cube and a 17-point profile like that, and that will give you 4,913 patches. You might also use drift compensation, which will help with monitor calibration. The EIZOs are extremely stable monitor. Drift is really not any issue at all whatsoever, and it's one of the really great features of an EIZO monitor. So that would take, depending on the probe, on a reference probe like a CR100 or a Klein, probably take about an hour and a half to do. An I1D3 may take about 2 hours or so to do, and would be the same for the internal probe. But we're going to be using a new function within the ColourSpace application called Grayscale Plus, and this is using a small grayscale, the primaries and the secondaries, to create a profile and then a new engine to create the LUT management. So you can see it's only 27 patches. So once we're all happy to go, we just simply hit the start button, and the ColourSpace will then start to create the patches and read those patches and create a profile. So I always like to also look at the manual here and just keep an eye on this to make sure that there's no bad patches and there's no missing or misreads within the actual read itself. So this will take probably about 1 minute and 40 seconds. So this is running at real time now. Nothing's being sped up within this tutorial. So you'll notice here we're starting to populate the XY chart on the left hand side. And you get an idea of where things are at. You'll notice this is different because we haven't created the auto function to do the range. So this is reading higher than what that default was. But that's not a problem, we'll fix that in a minute. And now it's getting through the grayscale, and it's giving 109 when it's expecting 102. That's the reason there's the target from before. And you can see now there's the red down here. So the red on the CG319 is basically a DCI-P3 red, which allows you to get that calibration with DCI-P3, very good. And so once it's done that, it did 1 minute and 41 seconds. And then we can go and have a look at our results. So I should basically see a different gamma because we're on native. So when we go back to our settings, we talked about this target luma here. You'll see that this profile luma here is 109. So what you can simply just do is to go, and that will put that 109 back up into here. And so you'll see this gamma difference here because we're on Rec 709, but the gamma on the native panel gamma is basically a 2.2. So when we select the 2.2, which is sRGB, and we redo our luminance levels again, you'll notice it's basically a 2.2 gamma all the way across here, a little kink there. You'll notice here on our balance that the monitor is showing very, very blue, but the red and the green, they track almost identically. So that's basically the difference between our white point here for D65 and our point here. So we've actually created that profile now. So that's how long it's taken to do that. So all we simply do now is to go in and save that profile. So we come down here and we save the profile, and we'll call it Azo Internal Profile and Test, and we'll save that. So that's now saved. So we've profiled the monitor. So now we need to go and create a LUT. So we just simply select the LUT tools. Okay, so our LUT tools is now open, and it's very simple. You just select the source, which is basically what you're trying to calibrate to. It's a bit weird in the terminology, but that's what it's called, the source. And then we find our profile that we've just created. So here it is here, the internal profile test. We don't have any hint. That's an advanced function that's available within ColourSpace, but we don't need that for this situation. So here we call the LUT a name. So we can call it Rec 709, for instance. And then we just hit the create button. So sometimes this can take a little bit of time, depending on the quality of the profile and the quality of the monitor that you're profiling. Some can take minutes and minutes, but the linearity of the Azo with this is very, very good. Now, so what we're looking for here is a really nice, smooth, nice looking pattern. So you can see here that the outer box is the native profile of the monitor where it's brought it down. And if we look at our 1D graph, so there's no silliness going on there. So once we've done that, we now need to go and save the profile, save the LUT. So we go into the second tab called Manage LUT, and we simply hit Save. So once we've done that, that LUT is then ready to load into the monitor. So to do that, we simply go to the hardware options. Where our Unity bypass LUT was before, we go and select Rec 709, and then we go Upload. And the Azo monitors are pretty fast to do this. There's some monitors can take minutes and minutes. And so we've now uploaded that Rec 709 LUT within the monitor itself. And if you look at now your color selection, your mode on your monitor, you'll see that Rec 709 is now available as a choice. So what I like to do once I've done that is just to give it a bit of a quick check to make sure that at least the white point is what it should be, and then I can set that to 100 nits. So we're at 102. So what we can do is we can go and just put that on repeat and then hit measure. We go into our Azo monitor and we open the interactive controls. And we can go back to our measure. And we can just take that down to a different value, say 242. You can use the slider. I do find putting the numbers in is a little bit easier sometimes. I've got 99.932, and that's about as good as you want to get. 100.048. So very, very happy with that, and it's spot on. So what we want to do now is that to verify the monitor, we want to go and do our reference levels here. So all we do is we simply hit the auto button and it'll go to black and it'll sample the black in 3 levels, in 3 times, and then it'll do the same for the white. And it's gone through the black, now it's gone to getting to the white, and it'll measure the white, and you can see that that's now gone bang in the middle of D65, which is nice. And now we do have uniformity on with the monitor, so you can operate in a brightness mode, we'll give it a little bit more contrast ratio, but I think it's more important to operate in the uniformity mode, but that's purely your choice. So now we can go back to our display characteristics, and I'd always like to go and just run a little grayscale test to make sure everything is running as I would want it to be. And then we just go back to our manual measure. And you can see the DE coming through here, 0.4, 0.5. So it just goes up to grayscale and we measure that. And the reason I like to do this is before I'll do a large verification, which we will do in a moment, which I use a 1000 patch verification. And that gives us an ability to look at the entire color volume within the actual monitor itself and see how the LUT tested. Another important thing with verification is to actually use some test patterns and test signals. The Granger Rainbow, for instance, is a very good one to see if you have any LUT issues or clipping. Should be a nice smooth looking test pattern, and also material that you know as well. You can see here we've got very good results. That's just a minute and a half to do that. So that allows us to go and have a quick look, make sure everything's okay. There's the 3D look. There you can see that the green dots are delta E less than 1, so that's totally imperceptible to human vision. Is our EOTF. In this quick one, I've got a little bit of a kink here, but there's going to be some work done on the future larger grayscale within this, but it's nothing extraordinarily bad. And the grayscale balance is extremely good, and if you look at the grayscale delta E, that's very, very, very good. That's averaging like 0.5. So what I like to do now is to go into our characterization and do a cube and do a 10-point cube. So this will take about half an hour. We don't need drift compensation for this. So this will take about half an hour. So we'll set this off and running, and we'll go back and we'll put our CIE, and then I like to, as I mentioned, just put this on and just to make sure that. So we're nearly done here. You can see on the bottom here we're up to 998. And one more to go. Give you the white. And then defaults back to the black. It takes a little while to do 1000 patches, but I think it's worthwhile doing that just to get a good idea. So you can see all these green here. That means that delta E errors are less than 1, which is imperceptible. And you can see through the entire color volume, that's the primaries and the secondaries there, the entire color volume has been calibrated through ColourSpace with the internal probe and the internal test pattern generator. has produced very, very, very good results. Look at the balance there, it's all the way through. This is the grayscale delta E, as you'd expect, it's well below 1. But that only tells the grayscale. The volumetric view shows that the calibration has given a delta E error throughout the entire volume, basically, of less than 1, which is fantastic. Now, if you don't have time to do a profile of 1000 patches, what I do suggest you do is to do a memory with secondaries. So that'll give you the grayscale, it'll give you the primaries, the secondaries, and also the memory colors like sky, skin tones and that sort of thing, just to give you a good indication that everything is well with the calibration like you've done. So once you've done that, you should then go and save it and just call it whatever name you would like. And so you've got a record for your calibration in the future, and you can go and print that report out as well. So that's calibrating with the ColourSpace onto an Azo monitor using the internal probe and the internal test pattern generator.